All right, I've had a question in Unit 2, Lesson 5, about question number 25. So we have two pennies that are sitting on a table 1.2 meters high. Both fall off the table at the same time, except one is given a significant push. If the pushed penny is moving at 4.1 meters per second horizontally, at the time it leaves the table, which one lands first? And B, how far from the table does the push penny land? So first thing we want to do is we want to set it up. So we've got, let's call it penny 1. So we know for both pennies, delta D equals 1.2 meters, and it's down because we're sitting on top of the desk. So relatively speaking, we're going to land down. Now, I need to be a little bit more accurate here. So this is penny 1, and this is the vertical information. All right, so at the same time, penny 2, vertical information, it has the exact same delta D, 1.2 meters down. All right, the next one, both fall off the table at the same time. One is given a push. So let's say penny 2 has a horizontal component. So its horizontal velocity is 4.1 meters per second to the right. And we want to know delta D, that is the unknown for penny 2. Now, what else do we know vertically here? Well, vertically, we know that the initial velocity, because it just left the edge of the table. So here's my penny off the edge. So one of them is going straight down. The other one is following a parabolic path. But in both cases, both have a V1 of 0. So they weren't thrown downwards. All right? So both of them share that information. Acceleration is constant, so they both are experiencing 9.81 meters per second squared down. And we want to know the time it takes to land. So time is the unknown. Time is the unknown because that time is transferable. I can move that time from my vertical to my horizontal, so I can solve the horizontal. So let's talk about part A. Part A is which penny lands first. Well, they both have the same vertical displacement, they both have the same initial velocity, and they both have the same acceleration. So the answer to A is they both land at the same time. And that's the evidence above. I showed the vertical information for both of them. If the vertical information is identical, the calculation is going to be identical, so they both land at the same time. So we still have to find the time in order to move on to part B. So it doesn't matter which one we're looking at. I'm going to use delta D equals V1t plus 1/2 AT squared. Plugging in my information. So I'm going to make the assumption that down is positive, and it doesn't really matter which way you pick, it'll come out with the same answer. So if down is positive, I have 1.2 equals V1 0, so that's nice, that equation, that part of the equation goes to 0, 1/2 9.81 t squared, so I'm just solving for my time here, so we'll divide both sides by the 1/2 9.81, 1/2 9.81, and once we punch that through the calculator, and don't forget you need to square root your answer when you're doing your calculation, I get let's call it 0.5 seconds. So the pennies take a ½ second to fall off the desk and land. Now I can move on to B part, and I'm just looking for horizontal velocity. There's no acceleration in the horizontal, so D equals VT. I know my velocity was 4.1, time of a ½ second, so therefore we get 2.05 meters. So therefore, penny will land 2.05 meters away from the desk. All right. If you have any questions with that or specific questions that you want followed up with, let me know, and I will do my best to answer them.